Oh, hi y'all. Welcome to my little plot of land on the Nether roof. It's not much, but it gets the job done. I got a couch, a kitchen area, some bookshelf. There's a plant back there. Yard's nice. The neighborhood's really quiet. But I don't think you're really interested in the tour, are you? I guess you're visiting me today because you want to know how I acquired this fine piece of property. How I built on the Nether roof. Well, you're in luck today. I'm finally ready to reveal my secrets. I'm finally ready to explain how I build on the Nether roof in Minecraft Bedrock Edition. Before we get to that, I gotta take care of a few things. Because today is an important day. Today is the day that we finally celebrate this channel passing 1,000 subscribers. I especially want to thank all of my subscribers for your support. I've really enjoyed interacting with all of you and watching everyone use my tech in their own worlds. If you're watching this video and you're not subscribed, please consider subscribing. Because think about it. If I'm telling you how to build on the Nether roof at 1,000 subscribers, imagine what 10,000 will be like. I also would like to thank Navy Nexus and Old Guy for their support. Simply put, without their support for this channel, I would not be making this video now. This channel is only about a year old, but I've actually been playing Minecraft Bedrock Edition for 4 years. I started playing Pocket Edition Alpha 4 years ago with my sons. Initially, I played a mix of survival and creative with my sons while watching Minecraft videos on YouTube for ideas. Although most of the Let's Play videos that I watched were either on Java or console, and the mechanics were different from Bedrock, I actually learned a lot watching them. At the time, good information about Bedrock mechanics was missing on YouTube. For example, it was hard to find information about building good farms for Bedrock. What was available on YouTube was limited, wrong, or misleading. It was really hard to be a solo technical player. All that changed when I discovered the TechRock Discord community. TechRock! After joining TechRock, I quickly realized that if a YouTuber built a good farm or said something accurate about Bedrock mechanics, that was because they likely learned about it from the TechRock community. So I learned a lot after joining the TechRock community, and eventually started making my own tools for the analysis and manipulation of save game data. I wrote tools that allowed players to repair worlds, reset chunks, 5 mob spawners, and other things. Eventually, to understand the game more, I started reverse engineering Minecraft Bedrock Edition. I initially focused on figuring out the spawning algorithm, which led to solving a lot of open questions in the technical community. And right now I think I'm probably the only person outside of Mojang that understands all the subtleties of mob spawning in Bedrock Edition. A lot of high performance mob farms that you can now find for Bedrock use mechanics that I discovered through code digging. So I'm very proud of that. I've joined a few survival multiplayer servers, and I've had a lot of fun designing and building high performance farms on those servers. Some of my favorites include building a massive wither killer farm, an octuple cave spider farm, a shulker farm. I've built several zombie and skeleton farms. I have a thing for mob spawners, if you can tell. So being a solo technical player for a long time, joining a technical server with people who know what they are doing is amazing. The people I now play with on Exploit, Advanced Automation, and TechRock not only know how to build high performance farms, but also understand the mechanics and don't lie about their rates. There's a lot of semi-technical content creators out there who spread false information because actual game mechanics are uninteresting to them. The people I get to play with are not like that, and I love it. I now run my own Discord server focused on my tools, content, and the analysis of Minecraft. My Discord has evolved into sort of neutral ground where technical players can focus on the study of Minecraft mechanics without some of the noise present on other servers, and I want to keep it that way. My Discord's also the first place where I teased that I could build on the Nether roof in Bedrock. Now since then, I've answered some of your questions about how I built on the Nether roof, but I've never revealed the full secret. So are you ready to see how I build on the Nether roof? I need you to watch closely. First, we get a block in our hand, and then we right click. Did you miss it? I'll do it again. First, we get a block in our hand, and then we right click. Right click, right click, right click, right click, right click. That's it. That's all I need to do to build on the Nether roof. Of course, I am using a modified client. My client has an increased build limit in the Nether. And for the rest of this video, I'm going to explain how you can modify your client to get this to work. Right click. In order to explain how I modify my client to build on the Nether, I first need to explain how I reverse engineer Bedrock Edition. Now, because of the way Java is designed, users can access the source code for Java Edition. However, Bedrock Edition is written in C++, and there's no way to access its source code. I do not have access to any Minecraft source code. Instead, I rely on a program called Bedrock to analyze and decompile the Bedrock dedicated server for Linux. Bedrock's decompiler doesn't generate Bedrock source code or even valid C++ code, but it does give an approximation of that code that is useful for reverse engineering the game. Now, I don't recommend everyone go out and run Bedrock themselves thinking that they will be unlocking the secrets of the game. Even on my beefy machine, it took nearly 40 hours and lots of memory to analyze 1.16.100. Beyond that, Bedrock is not perfect, and it takes a lot of manual editing to make sense of the result. I'm able to do this because I have about 25 years of experience in C++, and I have invested over a year learning how to apply Bedrock to Bedrock Edition. As you know, there are 3 dimensions in Minecraft: the overworld, the end, and the Nether. So in Bedrock Edition, information about dimensions is stored in a dimension object. So what you're looking at here is the constructor function for the Nether dimension class as inferred by Bedrock. So the first thing this function does is it sets up to call the constructor function for the dimension class, because a Nether dimension is a dimension. So the first thing it has to do is set up the base class when it constructs a Nether dimension object. Now, one of the parameters passed to the dimension constructor is the dimension height range. So dimension height range is a pair of values, in this case 0 and 128, that specify the bottom and the top of the dimension. Now, this is a change in 1.16.100 because before then, only the height of the dimension was passed. So in 1.16.100, they also had the bottom passed. So what this tells me is that Mojang is preparing to implement negative coordinates in the Cave and Cliffs update, because there's no reason to make this API change unless Mojang is preparing for the bottom of dimension to go below 0. So my prediction for the Cave and Cliffs update is that the Deep Dark is going to have negative Y coordinates, or at least that they're willing to make an API change to experiment with that. So I want to call your attention to this number. This number is 128 in hexadecimal. So this is the number that specifies the height of the Nether. So when modifying a client to support a higher build limit in the Nether, we have to find out where this number is in our client and change it from 128 to 256. So that is our goal. So if you remember from earlier, this is not the Bedrock source code. This is only an approximation of it. We cannot change this number here, save a file, recompile it, and get out a functional program. Bedrock just doesn't work that way. So instead of looking at this view, which is of the decompiler output, we're going to click over here and we're going to look at the assembly output. So compile program, like your Minecraft client or a copy of Bedrock dedicated server, is a series of machine instructions that tells your processor how to operate. And the assembly output that you're looking at here contains the location within the file that an instruction's at, the instruction in binary, and a translation of that instruction to a format that is human readable. For example, this instructor here calls the constructor for a dimension height range. So the instruction that loads the build height of the Nether is right here. So this instruction takes the value 128 and loads it into a register that will be later passed to the dimension height range. So to sort of unpack this machine instruction, so the bytes 41 and B8, so these first two bytes, these are what tell the processor that you're going to be storing a value in the R8D register. These 4 bytes that come after it, these are the bytes. This is a 4-byte number in little Indian format that specifies 128. So if you wanted to change the height of the Nether to say 256, we would change these 4 bytes to be 00, 01, 00, and 00. So that's what we'd have to change. So we would go to this location and change these 4 bytes. And we'd have a modified version of Bedrock Dedicated Server 1.16.100 for Linux that has an increased Nether height. So the Bedrock Dedicated Server for Linux is a bit easier to do this on because of how it's compiled. For the Windows client and the Windows Dedicated Server, this is much harder to track down where to find the instruction that needs to be changed. So we wanted to modify this value in Windows Client or Windows Dedicated Server. We can't go directly to the Nether dimension constructor and modify this value. So we have to come up with another strategy to locate where that value is, and that's what I'm about to show you. So in order to track down where the constructor function is for Nether dimension, I want to call your attention to the dimension function. So the dimension constructor, it sets up a whole bunch of stuff related to dimensions. I want to call your attention to down towards the bottom where the population caps are set up. In particular, I want to call your attention to this population cap right here. So this is the population cap for water animals, and that value is 36. So if we look at the function over here in the assembly, so in this value, so we are moving to a location in memory, the value 36 as a floating point number. What's interesting about this is that this set of values only appears once in the game and only appears in this dimension function. So how we're going to track down the constructor for the Nether dimension in Windows Client and Windows Dedicated Server is that we're going to look for this value here. That's going to tell us where the constructor for dimension starts. Then, once we know the location of the dimension constructor, we can then find the 3 functions that call it. One of those is going to be the constructor of the Nether dimension, one of those is going to be the constructor of the overworld dimension, and the other one's going to be the constructor of the end dimension. Once we find those 3 functions, we can then identify the Nether dimension. We can then read its assembly code and figure out where the instruction is that sets the Nether height and modify that. So I'll run you through how to do that. So the next part of this video, I'm going to be using a Linux terminal session to disassemble a copy of Bedrock Dedicated Server for Windows and use that disassembly to figure out what I need to change to raise the build height and the limit on Windows Dedicated Server. So the first thing we're going to do is we're going to use a command called object dump to disassemble Bedrock Dedicated Server.exe. So the command to that is object dump -d for disassembly -m intel. And so that's going to give us an Intel output on our disassembly. F to include file headers. And then we're going to include Bedrock server.exe. And we're going to pipe the output to bdsasm.txt. This takes a bit, but when it's done, bdsasm.txt is going to contain the disassembly output of Bedrock server.exe. So we can use a command called less to look at our disassembly output. So less bdsasm.txt. We press enter. We now see the beginning of our disassembly output. As we saw earlier, this disassembly output has a location, followed by a machine instruction in hexadecimal, followed by a human-readable translation of that machine instruction. So while we're here, I want to call your attention to the beginning of our disassembly output. And it tells us that the location of 14000100 is at the file offset of 0x400. And so we will use this later on in order to convert our chosen position back to a file offset. So keep this in mind, because later on when we identify the instruction location we want to modify, we can use this information to identify where that instruction is in our file. So if you remember our analysis strategy, we're going to look for the number 36 stored in a single precision floating point value. We're going to use that to identify the function that is the constructor for our dimension object. And then we're going to use that function to identify the nether dimension constructor. First, to exit from list, we're going to press Q. So now we're going to use the command grep -n. So this is going to give us line numbers. And then we're going to search for the number 0x42100000. So this is the hexadecimal encoding of the number 36 as a single precision floating point value. And then we're going to pass our BDS ASM.txt file. So when we run this, we see that the line number 5057322 has the instruction that we're looking for. So there's a move instruction here that moves 36 into memory. So now we can run less again, but this time we're going to go directly to this line number. And the command to do that is plus 5057322G BDS ASM.txt. So when we run this command, it's going to take us directly to the line number that we're interested in. So if you see, we have our move instruction that we're looking for that moves 36 into a value in memory. And we have several other floating point values around here that are being moved into memory. So this looks like the constructor for the dimension object that we saw earlier. So next thing we do is I'm going to actually scroll up until I find the beginning of this function. So we know this is the beginning of our function because of the return up here from the previous function, the spacers put in between the functions, and this looks like the beginning of a function where it's setting up stack space and saving registers and stuff. So now, and because of all that, we know that this line is the beginning of our dimension constructor. And we're going to copy this location. So once we copy that location, we're going to use that to search again. So we're going to use grep-n. We're going to look for 0x and then our save location. And we're going to use BDS ASM.txt. So we're going to do this again. And so as you can see here, we've identified 3 locations that call our dimension constructor. One of these corresponds to the constructor for the overworld dimension. Another one corresponds to the constructor for the end dimension. And the third one corresponds for the constructor to the nether dimension. So we're going to go to each of these locations one at a time and see which one of these corresponds to the nether dimension. So our command to do that, again, is our less command, plus 5451901G. And then we're going to pass BDS ASM.txt. Press enter. And we're taken to that location in our assembly output. And you see here is the call at the beginning. So now I'm going to scroll back and see if I can tell whether this is the nether constructor or not. So I can tell right away that this is the nether constructor. So the way I can tell that is this instruction here is the construction of the dimension height object. So unlike the previous code that we saw, this code has been optimized and the construction of the dimension height object has been simplified. So this is the binary equivalent of the dimension height object. So the lower 2 bytes in this number correspond to the minimum value of the dimension height object, and the upper 2 bytes, these 8 zeros and 2 more zeros that aren't shown, correspond to the height of the dimension. So now we've identified the instruction in this binary here that sets the dimension height of the Nether. Specifically, we need to change this number here, which is 128, to 256. Once we make that change, our Nether build limit will be increased. I want to talk about the Minecraft end-user license agreement for a bit. So if we scroll down to the end-user license agreement, I want to highlight this passage. So the passage states that if you bought the game, you may play around with it and modify it by adding modifications, tools, or plugins, which we will refer to collectively as mods. By mods, we mean something original that you or someone else created that doesn't contain a substantial part of our copyrightable code or content. When you combine your mod with the Minecraft software, we call that combination a modded version of the game. We have the final say in what constitutes a mod and what doesn't. You may not distribute any modded versions of our game or software, and we appreciate it if you didn't use mods for griefing. Basically, mods are okay to distribute. Hacked versions or modded versions of the game or client software are not okay to distribute. So what that means is that I can tell you how to modify your client to increase the build height in the Nether, but I can't actually distribute a modified client, and you can't distribute a modified client either. Otherwise, we'd be breaking the end-user license agreement in Minecraft. So now that that's taken care of, let's get back to modifying the game. Now that we've identified the location that we need to change in our server binary, there's lots of different ways we can make the change. Now you can use a general hex editing program on your machine to make this change, but I'm going to show you how to do it in RStudio. Now, if you're not familiar with RStudio, I'll put a link in the description of this video to another video on my channel that will introduce you to RStudio. Now, within RStudio, I've already taken care of pasting in the assembly output that we're going to need to change. So this is for our reference. I've gone ahead and set up the position that needs changing based on the location in our assembly output and the 2 offsets we need to find the location in the binary. I've also gone ahead and changed the folder for I've also gone ahead and changed the working directory for RStudio to point to the directory that contains our Bedrock server program. So the first thing we're going to do is we're going to press Control Enter, and that's going to source this position line. So next we're going to use a function from the reader package to load bedrockserver.exe into R's memory so we can edit it. So now I'm going to create an object called bin_raw. That's going to be the result of calling the function reader, read file raw, bedrock server.exe. So what read file raw is going to do is it's going to read our binary file in bedrock server.exe and return a raw vector that contains all the bytes in the value. So we can look at this by looking at head, bin raw, and do Control Enter, and we see that we have a series of bytes from our file. So next we're going to look at the position. So if we do bin raw, position plus 1 through 8, and press Enter, we see that we have the exact same values here as in the disassembly output. So we have our location correct. So now we're going to change the payload of this instruction from creating a nether height that is 128 to creating a nether height that is 256. So to do that, we're going to do bin raw position plus 4 and then plus 1 to 4. And so that's going to give us these 4 bytes. So if we do that, Control Enter, we see that we get the 4 bytes we want. So now we're going to set to these values a raw vector that contains the values of 0x00, 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 and 0x01. So if we do that, press Control Enter, and then look at our Bedrock again, we see that we now have the correct change. So now this is going to set our nether height to 256. So now that this is done, we got to write our data back to our directory so we can run it. So that's going to be read r write file. What we're going to write Bedrock, and then the file name. So we're going to write this to bedrock server modded.exe. And then do Control Enter to execute. And now we've created a modded file into our directory. Next thing I'm going to do is I'm going to go back to my Linux terminal session and I'm going to double check that I did this correctly. So as before, I'm going to use object dump to dump the assembly of the new modded version of Minecraft. I'm going to look to see if the expected change is there. That's object dump. -D for assembly, -M intel, -F. Now we're going to use bedrock server modded.exe. From there, we're going to save that to bds asm.txt. So now I'm going to use less to look at the nether dimension constructor and see if the change is there. Less plus 5451901g bds asm.txt. So we're in our function. So if we scroll up, we will see that in the exact location where we expect, we are now setting the nether height to 256. So we are good. So now we could run Bedrock server modded, and we would have a modded Windows BDS that has an increased nether height. Now, modifying BDS only gets us halfway to our goal of being able to build on the nether. We also need a modified client because both your client and your server need to know about the increased build height in the nether. Now, if you're playing a local game, a modified client is all you need because that client also acts as your server. So setting up a modified client is a bit trickier than setting up a modified BDS, and I'll show you in a second how to do that. Now this patching script is specific for Windows Bedrock Dedicated Server version 1.16.201. The position of this change, and maybe even the change itself, is going to be different depending on whether you're in Linux or Windows, or you're doing a Bedrock server, or you're doing a client, or you're running version 1.16.201 or version 1.16.100. So the script is not going to work on anything else. If you try to run this on anything other than Windows Bedrock Dedicated Server 1.16.201, you're going to corrupt your program. And so only run this if you have the correct version. In order to simplify the process of increasing the height of the nether, I've created a script to modify Bedrock client and server binaries. To use the script, you want to first source it. So we're going to use source, https://get.io, jtf, capital O, U, and then we'll press enter. So what source is going to do is it's going to download the script from the web, and then it's going to source it. So then the function that that script contains is now usable in our studio. So the function we're going to use to modify Bedrock is patch nether height. The argument you want to pass to this function is the path to the file you want to try to modify. In this case, bedrock server.exe. When patch nether height runs, what it's going to do is it's going to read bedrock server.exe into memory, see if it recognizes it, and if so, it then patches it. So it will not patch any binary that it doesn't recognize. So that means that there's a limited set of binaries that have been written to the script that it recognizes, and it will patch them if possible. Also, if you note down here, it creates a backup of the file. So in case you want to go back to the original one, or if you want to, try a different patch or something, backup will always be created, and then the original one will be overwritten. So that's what patch nether height does. So if you open up this URL in a browser, you can look the source code for the script and you can read the comments at the bottom that tells you which programs it recognizes. The patch nether height function is only going to work on binaries it recognizes. If it doesn't recognize a binary, it's going to throw an error. So if we run this again on the modded version, you will see the type of error that it produces if you run it on the wrong version. So you see it says the error is fp in names.patchrules is not true. So what this means is that patch nether height does not recognize our current version of Bedrock server.exe because it's been modded, and it will not patch it. This is important because if you try to run the script on a version of Minecraft that it doesn't understand, say a future version, you're going to get this error. So this is why it's important if you're using something like Windows 10 to install a version launcher. So if you have a version launcher, then you can pin your world to a specific version of Minecraft, and updating the game isn't going to impact your game. So if like the game updates, but you're still on the old version, you can still have your modded version and you can still keep playing your worlds. Because if you try to open your world in a version that doesn't have this patch applied, you're not going to be able to see any of the blocks that you've built above the nether. The process for modifying Windows Client is a bit different than modifying the Bedrock dedicated server. And this is because the way Windows Store applications are stored on your game. So I highly recommend you set up a version loader. It's going to be much easier than what I'm about to show you, but it is possible to modify your game without loading a version loader. So the first thing we need to do is set up our computer to developer mode. So to do that, we're going to come in here and type developer and type developer settings. So what we're going to do is we're going to turn on developer mode. And so this is going to allow us to install a modified version of our game that doesn't have signatures and stuff. So this is a risk to do this. So you may want to turn this off when you're done playing with the nether roof. But for now, this is what you need to do in order to load a version of Minecraft that is not in the Windows apps directory. Click yes, and so now developer mode is turned on. So after this, we're going to open up a version of PowerShell that is in administrator mode. And so to do that, we're going to do come down here and do PowerShell and run as administrator. So one thing to note is that what I'm showing you right now, you cannot do if you are not an administrator on your system. So first thing we're going to do is we're going to locate where Minecraft is currently installed on our system. And to do that, we're going to use a command called git appx package. And then we're going to pass it microsoft.minecraft. And we're going to put a wildcard, so an asterisk for a wildcard. So when we run this, this is going to check our database of installed Windows Store apps. It's going to look up Minecraft, and it's going to tell us information about the installation. What I want you to note here is the install location. So this is the directory where the game is installed. Now, normally, if you're going through Windows Explorer, you couldn't get access to this. But because we're in an administrator PowerShell, we can go directly to this folder and work with it safely. So what I want you to do is I want you to highlight this install location and right click on it to copy it. So now that's copied into our clipboard. So the next thing we're going to do is we're going to make a copy of this directory into our documents folder. So to do that, we're going to use a command called xcopy. We're going to pass the flags EHI. Then we're going to do quotation mark, right click, and that's going to paste our folder that we're going to copy from. Then we're going to pass a path where we want to copy it to. So in this case, I'm going to do it to home. $home / documents / Minecraft copy. So this is going to take a bit, but it's going to copy everything in Windows apps into a local directory. Now this is important because although we can read from Windows apps, we cannot edit or modify any files in there. So what we're going to do is we're going to copy everything out of the Windows apps directory into our documents, edit them there, and then we're going to set up the new location as our Minecraft location. So next thing we're going to do, we're going to change our directory to our copy. So that's going to be cd home / documents / Minecraft copy. So if we now look at this, we do dir, we now see we have a copy of our Minecraft directory. So two things to note here. So Minecraft Windows, this is our client. This is the program we will be editing to increase the build height of the Nether. This other file, app signature P7X, we need to delete the signature file because if it's there, Windows won't let us use this copy of the game as our primary Minecraft copy. So to delete it, we're going to do delete appx signature.p7x. So now that's done, we type dir again. We see that it is no longer in the file directory. So we now have a personal copy of Minecraft ready to be enabled as our main copy of Minecraft. But before we uninstall our main copy of Minecraft, we need to make a backup of our local data so it's not deleted during the installation. So to do that, I'm first going to run git appx package Microsoft.Minecraft asterisk. And so in the output of this, I'm going to copy package family name because we're going to need to know that. So I'm going to highlight that and right click. So that's going to copy it to our clipboard. So now I'm going to type move $$ $env : local app data / packages / and then I'm going to paste our package family name / local state : or $env : local app data / temp Minecraft. So this is going to move our local data into a temporary directory, which will then allow us to remove Minecraft without deleting it. So next we're going to go up here and we're going to copy the full name, highlight it, right click, and we're going to use the command remove appx package, then we're going to right click our full package name. So when we do this, this is going to uninstall Minecraft from our user account. So next we're going to reinstall Minecraft, but we're going to use our local personal copy. We're going to use add appx package, register, then we're going to use ./appx manifest.xml. Press enter, and this is going to register our command. Now, if you get an error here, maybe because you're not in development mode, so make sure you are in development mode, and this should work out for you. So to check that we did this right, we can run our git app package again. So press the up arrow, and we can run our git app package again, and we see that the install location of Minecraft is now my local copy. So next we're going to copy our local data back into the right folder. So the command to do that is move $env : local app data / temp Minecraft / quotation mark again, env colon local app data slash packages slash, I'm going to right click. This is going to paste our package family name in there, and we'll do local state. So this, when run, is going to copy all of our backup data back into our local state, and we should be good to go. So to check, I'm going to go down to my folder, and I'm going to go to app data local, packages, check Microsoft Minecraft, local state, and we see that we have our data back. So we should be good to go. Last thing we need to do is delete our temp directory. So that's delete del environment local data, local app data slash temp Minecraft. So now that directory is removed. So now we've set up our personal copy of Minecraft. We've restored our user data. So now the next thing to do is we're going to run our studio, and we're going to modify our copy of the game. So I'm going to come up here first. I'm going to change my working directory. Session, set working directory, choose directory. I'm going to pick Minecraft copy. So this is going to point me to the directory where Minecraft is. So next I'm going to source https://git.io/J-TFO and U. Press enter. That's gonna download our patching script, create our patching function, and now I'm gonna run it. Patch Nether height parentheses. Now the argument is going to be Minecraft dot windows.exe. So now, as before, this is going to load Minecraft windows.exe into memory, see if the script recognizes it, and if it does, it's going to patch the height. So now this is completed. We did not throw an error. So now I'm going to run Minecraft and see if I can build on the Nether. So we're in a fresh new world, and I'm going to quickly build a Nether portal and see if we can build on the Nether roof. Give myself some obsidian, some flint and steel. Quickly build a Nether portal. We're going to the Nether. I want to dig up. We're now on the roof, so the question is, can we build here? Right click. We can. So our patch was successful. Our client recognizes that we have an increased build height in the Nether, and that's what I call parity. Right click. Alright, so I've shown you how to modify Bedrock dedicated servers and desktop clients to increase the build height of the Nether. Do you know what that means? It's not long until someone does a Nether roof SMP in Bedrock. It's called parity, and I'm excited. Some of you probably want to know if it's possible to modify mobile and console versions of this game. And my answer is maybe. It's possible that someone can do it using the information in this video, but it's not something that I do. I'm sure if someone comes up with a solution, it will be mentioned in the comments of this video or in my Discord. So keep your eyes open for it. Also, do not install any modified versions of this game that you find on the internet. Those installations break Minecraft's EULA and are potentially harmful. There's a few more things that I need to cover before we go. 1. Check out the description to this video and the comments for the latest information on this tutorial. 2. Back up your important worlds before you try to patch your game. If you make a mistake during the patch, you could lose your worlds permanently, so making backups is very important. 3. Install a version switcher. I didn't cover version switching in this tutorial, but it is really useful. A version switcher would take care of most of what I showed in my Windows 10 tutorial and allow you to download previous versions of the game. Version switching is also important because I do not plan on updating my patching script for every version of Minecraft that comes out. So you want to be able to choose a version that my script supports. 4. Backups, backups, backups. And 5. Thank you all for the support that you've given this channel. It means a lot to me. If you are not subscribed and would like to see more content like this, please subscribe to this channel. Also, join my Discord. There's a lot of stuff in my Discord that hasn't made it to this channel. So if you want cutting edge knowledge about Bedrock tech, that is the place to go. So I'm Rufus. Thanks for watching. Right click.